themselves should follow the rules of these, additions and these transformation. Now the reason I asked you whether the current could be a scalar or vector, the answer is that current is nothing but a stream of charges, a stream of electrons that are flowing in a metallic wire or any object. But you cannot change your stream of electrons if you look at it from other direction, can you? Because the number of electrons in that object is fixed. Now, the number of electrons in the object is fixed, the number of electrons in a metallic wire is fixed itself. So, if you wave the current by tilting your head, for instance, or let's say if you waved it from a rotated coordinate system, then you see you still would not have different number of electrons flowing in different direction, because the number of electrons is clearly fixed. So if we look at vectors from this perspective, not as some quantity that has a magnitude and a direction assigned to it, that if we look at vectors as quantities that are following this transformation rule of rotation, that is what vector really is, then current actually comes out to be, current by definition is indeed a scalar, not a vector. So that is what you, this is basically the definition of a vector. This is how you define a vector itself. Going by this definition, we know that we consider a number line over here, we can consider y also here. You clearly see that the way we have defined vectors itself uses coordinates. Position is nothing but the coordinate on that specific axis. So what you can say is that position itself is a vector. Position by definition is a vector. And you might have learned it in vector algebra that the difference of two vectors is a vector. That what it means is that displacement is also a vector. It is as simple as that. Position is a vector, displacement is a vector. Now the thing is, distance, is it a vector? The answer is no, distance is not a vector. Reason, it does not follow these rules. And why it doesn't follow these rules? The reason is, if you are to go from here to here along this kind of path, let's say from a initial point A to a final point B. So if you were to move from A to B in, let's say, this sort of path, the positions and the displacements, definitely if you are to rotate the coordinate system, you would see accordingly the positions and displacements would rotate themselves, and they are clearly vectors. But the total distance, the meter stick shows you, does not change. What is this distance in the original sense? The path taken, the path covered by the object. What is the path covered? How do you measure it? What you do is lay out a meter stick and measure the number that you are getting overall on the meter stick. That is what it means. So in this particular case, even if you were to wave this entire system, this entire thing with a rotated coordinate system, with a, let's say, rotated world itself, you would see that the number on meter stick still remains the same. That does not indeed change, because it is strictly defined by a physical object and you are not changing the length of that physical object. Distance has been defined according to that way. You are not changing the length of a physical object, the separation, actual separation, this kind of separation between the 2 points. That is why, since it does not change, what you get from here is that distance is a scalar. Distance is a scalar quantity. So from here we can clearly look that displacement, distance is indeed a scalar quantity, position is a vector, displacement is a vector. Then we can clearly understand the differences between displacement and distance. First of all, the difference is that of a vector and a scalar. Displacement will give you information only about the final and initial positions of the point, where the point finally was, where it initially was. It is basically a separation of end to end points, that if it went from A to B, if it has certain displacement that you call, for instance, delta x. So this delta x is related to two positions, the initial position and the final position. Both our displacement and distances are very important in our study of kinematics. Why? Because displacement will give you information about the initial point and the final point of the system or of the object.